What's going on? So we're back in Reaper and we want to create a script that will, for want of a better term, forecast the file size that it would be if this was a render region. Now, I think the way that we want to do it is we want to use the timeline selection like I have on screen. So that way, you know, if you have this item selected, it'll tell you how big it would be if it was 44.1 16-bit stereo and mono and 48 kilohertz 16-bit or 24-bit, all the different combinations. So yeah, that'll sort of be the way the script works. The user should make a selection, timeline selection, run the script, and it tells you in the console log what the different sizes will be depending on the different formats, sample rate and bit depth, and whether it's mono or stereo. Just quickly, in case you're interested, the shortcut that I'm using there, set time selection to selected items, skip if time selection exists. So that's how I'm doing that real quick. So that's a handy one that already exists as part of the SWS extensions. Okay, let's get into it. So new action. Calculate file sizes from time selection. Cool. So we've got our main set of instructions and then we call them at the end. All right. Cool. So we need to get the timeline selection start and end points and thus calculate the duration. So store that as a variable. And then we're also going to want, so how that works is when you store something like that, it's going to be like 9 point, 1, 2, 5, 6, 7, it's going to have like 7 or 9 decimal places. So then we want to create I'm going to say 2 decimal place version of that number, because when we print it out to the log, it'll just be a little bit neater if it's just 2 decimal places, not 9 or 14 or however many the data type allows. So yeah, create a 2 decimal place version for the console output message. Okay. So in a table up here, we're going to define the different output messages and different parameters. Output parameters, I'm not sure what to call this table. Cool, so this will be a table. Every entry is also going to be a table. So I don't know if we've done this in any of these video series, but you can have the entries of a table be tables themselves. So a table of tables. That's something you can do. So how I'm going to structure this is every item in each table in the interior of this big table, Jesus, every item is going to have the same key. So SR for sample rate, 44100 bits 16 channels equals 1, right? And then a description the description is going to be 44.1 kilohertz, 16-bit, and channels 1. Cool. And then a comma. So that's one entry of our table structure. And I'll just do one more for now. Description is 44.1. So this description item, that's actually what we're gonna use this stuff in the calculation, but then in the display, it's gonna be this, and then the calculation, you know. It's equals 24, channels equals 1, description equals... Oh, nope. Oh God. Okay, let's leave it there for now. There's going to be 5 more. And, you know, you can customize the script however you want. Maybe you care a lot about 96K, so you want a bunch of 96K entries in there as well. But for my one, it's just going to be 44.1, 48 kilohertz. It's just going to be 16-bit and 24-bit. No 32-bit or any multi-channel stuff. Just simple. All right. Cool. So now what? How this is going to be is loop through each item in output parameters and calculate the file size. So that's sort of why we structured it like this, because you can loop through it like this. So for I value in I pairs, output parameters do. Now, I think in a previous video we have done a pairs for loop, but this is an I pairs for loop. Now, one of the main differences between pairs and I pairs is going to do it in order. And we want it to do it in order because when we want the output log, we want it to be, you know, this logical order, starting from 4416 mono, stereo, and then 24-bit, and then 48K. You know, it's in a nice order. That's one thing. The other thing about I pairs table is I pairs for loop is it's only going to work with a table that's structured like an I pairs table. Now, what do I mean by that? So you'll notice that this is just a list of values. And when I say a value, I'm referring to the table. So this is a value. The value is a table with all the stuff in it. This is a value. So it's just a list of values. And when you've got a list of values, it's implied that it actually looks like this. So putting in these ordered integer indices like this actually didn't change the table at all. Because when you only have values, it's implied that they're ordered, indexed 1, 2, 3, etc. So when it is, when the key is ordered indices like this, 1, 2, 3, 4, 5, 6, and then the value can be anything you like, that's what constitutes an I pairs table. So yeah, this is an I pairs table. Maybe we can write a note for that. This is an I pairs table because the keys are ordered indices. When a table is formatted with only values, like below, it is automatically an iPairs table in that it automatically has index keys. Okay, so this is an iPairs table. Too long, didn't read. This is an iPairs table. Okay, cool. All right, so what are we doing? So for Ivy and iPairs, our parameters do, based on the duration we have stored, calculate the file size. Print this information to the console. So those are the two things that we're doing. Cool. So the formula for this stuff are these two guys. So we calculate it twice, once for kilobytes, once for megabytes. You know, if you happen to be into the gigabytes range, then, you know, you can probably figure out that it's like, you know, if it's like 2000, it's like just under 2 gigabytes. If it's really important to you, you could add in like a size in gigabytes one as well. I don't think it's really necessary though, but you might disagree. All right. And so we want to pick one of these that we're going to show. So how we're going to do that is if the size in megabytes is 1 or higher, display megabytes, else display kilobytes. Seems reasonable, right? You know, I don't like to see 0.7 megabytes. I don't like that. I'd much prefer to see 700 and whatever kilobytes. And likewise, if it's, I wouldn't want to see 1,500 kilobytes. I'd rather see 1 point something megabytes. Hopefully you agree with that. So let's do a output size is size in megabytes. And then we're actually going to make it a string because at the end of the day, we're just printing strings to the console. So if you concatenate that with megabytes, this whole thing is now a string. And notice how I put it in the space there. That's important. Well, not important, just aesthetically important. All right, so outputting megabytes is the default, but then if size in megabytes is less than 1, then we overwrite the output with the kilobytes version. That's how we're going to play that one. Capital KB or lowercase kb? I'm not sure. What's the convention? Maybe it doesn't matter. All right, that'll do for now. Cool. So, yep. Right, so, you know, we just copy and pasted this, but that's not actually going to do anything. Sorry, I'm jumping all over the place. Those are the formulas, but, you know, we need to actually get those numbers, don't we? And those numbers are up here. So, how we do this is when you're iterating through a loop, V, in this instance, I've said V, you can do anything. You can write a word. It's just a new variable that you're generating. So what it is V is the value for that iteration loop. So V is one of these tables, okay? So if we want to access the sample rate of this value, it is v.sr. So if we're doing the first iteration, we're looking at this one. v.sr will be this, okay? And likewise, if we're in the first iteration and we want to access this bit, it's v.bits. So it's v, this is v, and then we're accessing, inside of v, we're accessing bits, hence the dot bits. Okay, and this one will be v.channel, and duration we calculate elsewhere. Cool. All right, so then we print the information to the console. So we need to sort of think how to structure it. Yeah, maybe we'll write an example. 9.21 seconds. And then it's going to be one of these, right? And now I'm just going to have to make up a value. Equals? Do we want equals? I don't know. Equal? Yeah, sure. Equals. I have no idea. I'm just going to have to make something up. Let's say kilobyte. So that's sort of the structure of what we want it to look like when it comes up as the output, right? So I just wanted to write that there so we sort of know the goal. So we have our main output string that we're going to print. So we're going to use the formatted version, which we haven't got yet. But we can give it a name for now. Formatted duration. And this is going to be duration. Right. So we want the formatted duration. That's the 2 decimal place version. Formatted duration concatenated with this. Concatenated with and then this whole thing is our description. So that's going to be v.desc because we're still in that loop, right? So if we're looking at this one, and we want to access this, it's v.this, and that'll give us that value. So v.descr. Cool. That's good for now. There's a few other steps, but I want to build up to it. So show console message. That's the one. So this is a good one because it you can do this multiple times, and the messages are just one after the other. So it's kind of ideal for what we want here, rather than using one of those pop-up boxes, because then it'd be pop-up box and then the next one. Rather than having them all displayed at the same time. That's the way to go. So let's just do this. Let's just put in some dummy numbers like this. And let's see if we get stuff. Okay, cool. So it did do it, but have a look. So channel. It didn't do the calculation. Whoops. And we didn't do the final calculation. Whoopsies. Equals output size. So we want that. Okay. So there it is. That's one. And then here's the next one. Now you can see how hard it is to separate the lines. Now we have a solution for that. If you put in one of them, that's a line break return, a character return, new line character. That's the one. So now if we do it, they each have a new line character. And what I like to do actually is after the whole loop, put in another one. So that way, if we run the script more than once, see that? You can see clearly where, you know, we ran the script this first time and then we ran it again. Yeah. So yeah, I feel like that's a good one. Okay, cool. So we're getting somewhere. But these are not real values. So let's deal with that now. Get the timeline selection. All right, so that one is from memory. It's one of the get set. Yeah, I think it's that loop time range. It's another one where there's a version 1 and then a version 2. Allow auto seek number start. Not sure what the difference is. Allow auto seek. Oh, this one you pass in a proj. Maybe that is safer. Let's do that. So yeah, it's one of those functions that's a combination of getting and setting. So we're just getting for this one. So that we want those return values. It's all about those return values. All right. Cool. So timeline start and timeline end equals, we want a reference to the active project like we do in pretty much all of our scripts. So is set is false. We're not setting, we're just getting. Is loop, that's also false. So one of the things that we can do to save space is you can declare two new variables on the same line, and it looks like this. So is set has the value false, is loop has the value false. And then from memory, you know, these are parameters for when you're setting. So yeah, when you're just getting, I think you just do 0, 0 and false. I think we'll have to see how that goes. Yeah, we'll come back to that if that's an issue, but I think that's how to do it. So, you know, when it spills over the screen like that, I usually like to do that so you can see it all. Okay, so yeah, the duration is going to be the end minus the start. All right, now the 2 decimal place version. Now this is actually quite tricky. So some of the tools that we can use, one of the inbuilt Lua functions is math.floor. And what that does is it gives you the rounded down version of a number with decimal places. So math.floor 3.3 gives 3, 7.1 gives 7. So that's not like the whole kind of story for us, because we don't want a 0 decimal place value, we want a 2 decimal place value. So maybe it'd be a good time to pause the video and see if you can think of a way to use math.floor to get a 2 decimal place value. And like in all the videos, if you don't want to do that, that's fine, just keep watching. So how I might do this, I might make a function for this. So we'll function get number to 2 decimal places, and we pass in a number. Yeah, I like to do that, especially when we're sort of when we have some maths operation that has a few different iterations, few different lines. And it also means that this function is reusable elsewhere, which is really handy. For instance, we might want to round the megabytes and kilobytes to this. I think we probably do want to do that. So yeah, let's do that. Okay, so how do we do this? So multiply the number by 100, round to integers using math.floor, divide by 100. Does that make sense? So if you start with 9 point this, it becomes, you multiply by 100 and it'll be this, and then math.floor takes it to this, and then divide by 100 takes it to that, right? That's sort of the process. That's how we're going to do that. All right. We might leave that there. So it sort of shows you how it's working. All right. So local scaled up number is number times 100. Local scaled up rounded number will be math.floor of scaled up, and then local num to 2 decimal places will be scaled up rounded divided by 100. And then this is going to be a type of function that returns a value. I don't think we've actually done that before, but we've definitely seen examples of other functions that return values. But I don't think, at least in this video series, I don't think we've done one ourselves. But then we're just going to return the number, right? Cool, so that's our function, provided I didn't mess it up. So this is where we want to get that value. So formatted duration is going to be this, and we pass in duration. So, and the return value is going to be stored on formatted duration. So we pass in duration, and then something I just want to note, when you get in here, that duration in the scope of this function, it's referred to as number. It's kind of like an alias, I suppose. So number in this example was our duration. So that's what we're working with. That might confuse some beginners. So yeah, I just want to, maybe I'll just talk through that one more time. When you define the function or the set of instructions down here, the name of this argument that gets received, it doesn't have to match what you put into it. I mean, I suppose that's the whole idea of having a function. It's generic enough to receive a number from anywhere and work. It's not sort of specific to this example where we're just using the duration. So that's why I'm able to pass in the word duration, the variable duration, and then number is now duration in this instance. But if we used it for the megabytes, for instance, you could pass in megabytes into this function call, and now number is referring to the megabytes value. Hopefully that makes sense. All right, so we have our formatted duration. Now there's something missing here because, oh, duration is there. I was about to say, where does duration come into the formula? But there it is at the back end. Okay, so one thing to note, this calculation is on the original value. It's not looking at the rounded value. I think that's probably the way that we want to go with it. Even though this is a slightly inaccurate reading. Sorry, this is a slightly inaccurate reading of the duration, whereas the size in kilobytes is very accurate. But I think that's okay because it's more about the size value rather than the duration. All right, let's give this a go. There we go, 10.22 seconds. And it's 880 for mono 4416. And slightly more for the others. They all look like they add up pretty well. Nice. And I'm not too fussed about the rounding, actually. Maybe that is something that you could put in, but it's not really bothering me so far. All right, so I'm going to quickly fill this out with more values. And the good thing about how we've structured this is all we have to do is just add new entries to this table, and none of the other code has to change. It'll just add it to the list of calculations that it does because it's in a for loop, right? That's it. All we have to do is add this here, and then it'll become part of the output. See, now it's part of the output. So that's a really good way to go. All right, so I'll probably speed this up. Maybe pause the video and catch up with this. And if you've done that and you're satisfied, so now we have a bunch of different values. Cool. So I guess as a last step, we could look at rounding down these. Now, I would feel that instead of rounding to 2 decimal places, we probably want to round to 3 decimal places for the sizes. So maybe it'll be a different function. Number to 3 decimal places. So for this one, it's going to be the same, but we're going to multiply by 1,000. So it's going to be pretty much exactly the same. And instead of, we can actually do it slightly differently this time. Instead of, doing all these different variable names, we can just keep overriding the same one. What I mean by that is, you can, actually, let's do it underneath each comment. You can just override the number with that step. So number times 1,000. Right. Number equals, what is it? Math.floor number. Cool. And then you divide by 1,000. Number equals number divided by 1,000. And then you return the number. Very nice. All right. Cool. So I suppose we would then override this with the rounded version. So size in kilobytes equals that function, and you pass in size in kilobytes. And this one here will be size in megabytes, will be passing in size in megabytes. So that overrides this. Sorry, overrides this with the rounded version. So let's just check that that still works. That's looking good. All right. And let's just check a longer region, maybe. login area, I mean. So 66 seconds. Yeah, it sounds about right. Cool. There you go. One hell of a script. So pretty handy, I would say. I've been in some situations where, like, when you're uploading something, it's a strict 10 megabyte limit, but maybe the format doesn't matter. So then you could run the script, like if the duration is set, you can run the script and then pick which one of these based on which is like 9 point something megs. Yeah, this is a script that I find fairly useful, and I hope you do too. So there you go. I hope you found that useful, and I will see you in the next one.